Hello Titans, we are now on lesson 3.4. This is Mr. Sturts. Let's grab those student journals and let's start taking notes. Okay, lesson 3.4 is talking about graphing linear equations in standard form. Our first slide here, horizontal and vertical lines we're going to talk about. A horizontal line is written in the equation y equals b, or y equals some number. Okay, and the reason we say that is because if we think about a horizontal line, let's say y equals 3. Okay, if we draw the line at y equals 3, that means it crosses our y-axis at 3. Okay, now any point, no matter what our x-coordinate is, our y-coordinate is going to be 3. Okay, if you think of 0, 3, that's right on this line. If we think of 1, 3, that's also on our horizontal line. We go right 1 up 3. Okay, no matter what our x-coordinate is, that point is always going to be on the y-axis at 3. Okay, now just the opposite. A vertical line is x equals some number. No matter what the y-coordinate is, the x is always going to be that same number. So in this, it looks like x might be 2. Okay, no matter what the y-coordinate is, x is always going to be 2. Okay, each point on there is x equals 2. It crosses the x-axis at 2. Two examples here. We want to graph y equals 4. Okay, so y equals 4, it's going to cross our y-axis. Remember, y is our vertical axis. It's going to cross our y-axis at 4. 1, 2, 3, 4. We're drawing a line directly through 4. Okay, it crosses our y-axis at 4. It's a horizontal line. Now for b, x equals -2. What this means is it crosses our x-axis. Remember, x is a horizontal axis at -2. So we have -1. -2. This is a vertical line. It crosses at -2. Okay, for this one, let's just think of an xy table. Our x is always going to be -2, no matter what y is. Okay, -2, -2. Let's just say we did our -1, 0, and 1. If we go left 2, down 1, that's going to be on the line. Left 2, 0, that's on the line. Left 2, up 1, that's on the line. Any point is going to have an x-coordinate of -2. Alright, next we're going to graph using intercepts. An x-intercept is where our line crosses the x-axis. Okay, that is where y is equal to 0. Okay, on this point right here on our graph, that crosses the x-axis where y is 0. Now y-intercept is just the opposite. That crosses the y-intercept. It's where our line crosses the y-intercept, and our x-coordinate is 0. Okay, notice here our x-coordinate is 0. So to graph using intercepts, we have to find both the x-intercept and the y-intercept. To find the x-intercept, we're going to let y equal 0 and solve for x. To find the y-intercept, we're going to let x equal 0 and solve for y. Okay, just opposite. So we're going to use intercepts to graph this equation here. So first, we need to let's find our x-intercept first. Okay, and to find our x-intercept, we said we're going to let y equal 0. So we're going to rewrite our equation, 3x, x stays as x, plus 4. Now instead of y, we're going to plug in a 0 because we want the y to be 0. That's our x-intercept. Now we just need to solve for x. Okay, 4 times 0 is 0, so those go away. 3x equals 12. Solve for x, we're going to divide by 3, so x is equal to 4. That's our x-intercept. That's where it crosses the x-axis. Okay, now let's find our y-intercept. Remember, y-intercept where it crosses the y-axis, so x is now going to be 0. So instead of x, we're going to plug in a 0. Plus, now we're leaving y alone, for y equals 12. And let's solve. Again, 3 times 0 is 0. 4y equals 12. We're multiplying, so do the opposite. Divide by 4, divide by 4. Y is equal to 3. Now, these are our two intercepts. So to graph this, very simple. Okay, we're going to take our x-intercept and we're going to go to our x-axis, which remember is our horizontal axis. And we're going to go over 4. 1, 2, 3, 4. Plot a point. That's our x-intercept. Now our y-intercept is 3. So we're going to go up 3. Plot our point. And now all we do is just connect our 2 points and draw our straight line. Okay, that's graphing using intercepts. Again, x-intercept is where y is 0. So instead of y, we plug in a 0. The y-intercept is where x is equal to 0. So we plug a 0 in for x and solve. Okay, so we have an x-intercept of 4, a y-intercept of 3. Connect our dots and we have our line. Now, a little word problem here. We're planning an awards banquet for our school. We need to rent tables to seat 180 people. Tables come in two sizes. Small tables seat 6, large tables seat 10. The equation 6x plus 10y equals 180 is our equation. Remember, x is small tables, y is large tables. So first we got to graph this. Okay, and we're going to graph this by using intercepts. Okay, so first we're going to find an x-intercept. Just like we did on the last problem, y is going to be equal to 0, so we're going to say 6x plus, instead of 10 times y, we have 0 now, because we're x-intercept, equals 180. 10 times 0 is 0. Those cancel out. 6x equals 180. Divide by 6, divide by 6. So x is equal to 30. That's our x-intercept on our graph. Now our y-intercept, let's squeeze this in here. Y-intercept is where x is equal to 0. So 6 times not x, but 0, plus 10y is equal to 180. 6 times 0 is 0. 10y equals 180. Divide by 10, do the opposite. We're multiplying, so we're going to divide. Y equals 18. Okay, so we have our two intercepts. X is 30, y is 18. Now let's throw our graph down here. For this problem, it doesn't make sense to have negative tables, negative people, so we're only going to graph our positive quadrant here. Now let's go to our x-axis. Let's count by fives. So 5, 10, 15, 20, 25, 30. Okay, and that's our x-intercept. It's 30. Okay, it crosses our x-axis at 30. Our y-intercept's 18. 5, 10, 15, 20. It's not quite to 20. We got 18. Okay, right close to 20. And let's connect our dots with a straight line. And there's our graph. So what this graph means, we got to understand what it means. Okay, down here at our x-intercept, that's where we have 30 tables. Now, 30 tables right here, our y is 0. Okay, that means we have no large tables. We only have small tables. Okay, and when we have 30 small tables, that seats 180 people. Now up here at 18, we have 18 large tables and no small tables. Well, 18 large tables also seats 180 people. Now every point on this line is a combination that would seat 180 people. Okay, so what part B is asking, find 4 possible solutions. We're going to pick out points on this line where it gets us to whole numbers. Now, this would be easier with graph paper. Okay, this isn't going to be very exact. But, for example, we could, let's trace over, let's say we're going to go to 10. Okay, 10 right here on our x-axis. That means 10 small tables. Okay, and 10 small tables, and let's go trace it up to our line and over. Okay, let's say, that's about 12. Let's say that's 12 on the y-axis. Remember, y is large tables. So if we have 10 small tables and 12 large tables, that should seat 180 people. Now, again, with graph paper, it's going to be more exact. Okay, but each point on this line is a combination of tables that would work. Okay, so we're going to pick out combinations on this line that would work. So we're going to say one possible combination could be 10 on the x-axis. Again, x is small tables. 10 small tables and 12 large tables. Okay, and we could write it as an ordered pair. 10, 12. Okay, and that's one possible solution. Now we could pick another point on the line. We could say maybe 25 and trace it over to our y, and maybe 25 and 5. Okay, that could be another combination. So that's how we're going to find our possible solutions. Alright, now that you're done with the notes, let's do our little extra practice. Turn to page 77 in your student journal and complete these 4 problems. 1, 2, 3, and 7. We'll check these tomorrow in class, and have a great rest of your night. Thank you.